Welcome back, folks. In this video, I want to show you how you can live stream head rotation data in to Unreal Engine using the LiveLink Face app. But before I get started with that, I had somebody ask me in the comments of my last video how you can strengthen or decrease the strength of the different morphs. And so let me show you how to do that real quick. So we're just going to jump into our LiveLink animation blueprint. And then it's actually really easy to do. We just create another modify curve node. So I'm just going to right click and then type in modify curve and select it here. And then we just need it, I would put it after our calibration offsets. So we're just going to connect the existing one to our new one and then connect the new one just to the output pose here. And then all we have to do is we select the new modify curve node and then we make sure the apply mode is set to scale. And then we just add a curve pin for any blend shape that we want to scale the value of. So I'm just going to kind of demonstrate jaw open because it's really easy to see the difference. So I'll select jaw open. And then right now it's at the default 1:1. So it's just timesing by 1. And you can see that's how wide his mouth opens. But now if we come over here and then we change the value to 2, and the reason this is at 0, so it actually would zero it out if I had compiled it, but I didn't compile it. But now I'm going to put it to 2 and then just compile it now so you can see the difference. And now, yeah, you can see that his mouth just opens twice as much. So that's just a really easy way you can kind of calibrate the blend shapes a little bit more if you need to. And so you'd probably more like, want to strengthen it by like 10% or something. So you'd put like 1.1 in there. But I'm just going to go ahead and put it back to 1 here to just make it the default value. And then I'll just put a comment on here just to kind of help organize things for myself and just call it the strength modifiers. And then just recompile so everything's back to normal. All right, now that that's out of the way, let's jump into the head rotation stuff. And so for the head rotation data, what we need to do is we need to capture the data coming in from the iPhone and then set some variables with it. And so there's a lot of different ways you can kind of go about it, but I'm going to kind of do it in the most concise and memory efficient way that I know of. And so what we'll want to do is we'll want to jump over to the event graph this time. And now we have this evaluate live link frame, and then you have to make sure that the subject is your phone. But you can see that it has all this data coming in from it. And it's basically all the morph target names at the top, and then right below them is all their current values that they're getting live fed in from the phone. And so if you see here at 52, 53, and 54, it has data coming in from the head yaw, head pitch, and head roll. But before those are actually streamed into Unreal Engine, you actually have to enable the setting in the app. So open up the app in your phone and then click the little gear icon. And then just make sure the stream head rotation is enabled. So right now I just disabled it and now I'm going to re-enable it. I think it was disabled by default. So if I can click it there, we just make sure it's enabled. And now we can minimize that, get it out of the way. And now it should be streaming that data into Unreal. So it's pretty simple. Okay, and now that the app is set up, we want to capture some of the data. And so what we need to do is we need to right click and create a get property value node. And then we see that data coming in. We need to capture the head yaw. So we want to grab the head yaw. And then we want the head pitch and the head roll. So we'll duplicate this with Control W, and then we'll just create, just set this one to capture the head roll, and then duplicate it again. And we'll just make this one grab the head pitch. All right, and now that we have our get property values, we need to make sure they're connected to this, the data that we're getting them from. So we'll just connect these guys. Just like that. And now we'll want to store the data as floats, but we can kind of do it in a single variable called a rotator. And so what we'll need to do is come to our variables section here, and then we'll click the add variable button, and then I'm just going to call this head rotation. And then if we come to the details section on the right hand side here, we need the variable type set to rotator. Now we can drag this guy onto our event graph, and then for this one, it'll bring up this little menu, and we want to set the head rotation data here. Okay. And so before we can set this data, we need to use a make rotator node. So I'm going to right click and do make rotator. And then we can see it here in the list. We just grab that guy. And then we'll connect this make rotator node to the set head rotation rotator variable that we just created. And so what this make rotator does is it just takes basically the X, Y, and Z float values coming in and then combines them into one variable essentially. And so that's all we're doing right there. And now the head, all these values are going to come in at a range between -1 and 1, but we actually need to change that to joint rotation values. And so the way we do that is we right click and we create a map range, and then I'm going to do a clamped one. So we want a map range clamp node. And then our in range is always going to be the lower one. I'll just use the A for the lower, so -1. And then the in range of B we'll use as the higher, so 1. And then we'll actually do different ranges for each of the properties. So for example, the head yaw, that's essentially like twisting the neck, so looking left and right. And so I just kind of pulled up I just Googled like normal head range for people. And so they can usually the range of motion is -90 to 90. And so we'll just put that in as our corresponding out ranges. So just -90 for the out range A, and then 90 for the out range B. And then we want to feed the head yaw value into that guy. And then this actually doesn't, even though it says yaw right here on the Z axis, that's not necessarily correct. It's going to depend on how your character is rigged. And so for DAZ 3D characters, if we jump into DAZ Studio and we click like the head, neck, and neck upper joints, we can see that their twist is actually on the Y axis, not the Z. And so I kind of have these memorized that X is red and green is Y and blue is Z. But if you don't know that, you can click the little gear icon here and then open up the parameter settings. And then you'll see that it has the Y rotate and the label is twist. And so that's just kind of a way you can figure that out here. You can also just experiment inside Unreal Engine, but I feel like it's a little bit easier just to, if you have a way of getting that information, just to check it and kind of have it right from the beginning. All right, so now that we know that the yaw is the Y rotate, we're going to cancel that and jump back over to Unreal Engine here. And then we want the return value to go to our Y axis. And then we'll just we'll duplicate this guy. And then so pitch is looking up and down. And so we'll have the same in range and of -1 to 1. And then the pitch is actually a little bit different. I just had to experiment to find this out, but it's actually, you want the out range of the A to be positive this time. And so we're going to do 70 and -70. Otherwise, it doesn't match your head. Like if you're looking up, it'll be looking down. And so, but yeah, so that's a simple thing to figure out though once you get this all set up. But I already experimented and found that out. And so now we want the head pitch to be plugged into this map range clamp node. And then the head pitch would be bend in DAZ Studio, so the X axis. And so I'll return this to the X, and then we'll duplicate this again. And then the roll is when you kind of turn your head into parallel with the floor. And so yeah, the in range is going to be the same, -1 to 1. And then the out range, sounds like the range of motion for typical people is -45, or it's about 45 degrees each way. So this one, so we'll do -45 and 45. and then we'll put that into the yaw. And then I actually got a little bit ahead of myself here by creating this make rotator. I'm going to drag these over a little bit to give us a little more space, because we actually have 3 joints that make up the kind of like the head neck movement for DAZ characters. And so I actually want to break the incoming head rotation data and feed it to 3 separate joints. And so we'll create 2 more variables, essentially one for each joint, but since I already have the head rotation, we only need 2 more. So we'll do neck upper rotation, and then it's already set to the variable type of rotator, since that's what I used last. And then we'll create another one, neck lower rotation. And then we'll drag both of these onto our event graph. And then we also want to set the values for these. All right. And then we'll need another 2 make rotator nodes for these guys. So I'm just going to duplicate this. There's one, duplicate again, and then there's a second one. And then the way I like to set it up is I like the head rotation to use 40%, to make up 40% of the movement. And so what we'll do is we'll right click and then create a multiply float node. So if you just type in multiply, then we select the one in the float section here. So float times float. And so then we'll need 3 of these for each make rotator node, so a total of 9. So I'm going to duplicate it, and then do it again. And then I'll just do them 3 at a time here. So we just take the return value of our map range, and then these are all, the value for each make rotator will all be multiplied by the same. And so we take the return value of the map range clamp, we feed it into our multiply node, and then we're going to use for the value here, I like to put 40% of it, so I'm going to put 0.4, and then we'll feed this to our pitch instead. So it'll be scaled basically to 40%. And then I'll do the same thing for the roll. We'll feed it into one of these multiply nodes, and then we'll do 0.4 again for 40%. And then feed that one into the yaw, since that's what it was connected to before. And then same thing, we'll take the map range clamped of the pitch node, and we'll multiply that by 0.4. And then we'll feed that one into the roll. Okay, so now that's set up properly. So we're just taking the our new ranged values, and then we're scaling them to 40%. And then we're making a rotator with those values, and then we're just setting it as a variable. And so we'll kind of need to do this again for the other 2 variables that we created. And so I'm going to take these and just duplicate them. So now I have the 3 new ones. And I also like 40% for the neck lower. And so we just take the return values and plug it into the top slot of these duplicated multiplication nodes. And then it's going to match the same, since all 3 of these joints are the same bend, twist, side to side. They all twist on the same axes. We just feed them into the same slots on our make rotator nodes. And so the head yaw goes into pitch. The roll goes into yaw. And the pitch goes into roll. And then we just need to return the return value of our make rotator node to set the neck rotation, neck upper rotation variable that we created here. And then again, I'm going to duplicate these 3 guys one more time. And then this time, since we have basically a total of 80%, we're going to, instead of doing 0.4 for these, we'll change it to 0.2 for the last remaining 20%. So I'm just going to do that real fast. And then the same thing, we just plug our mapped ranges to these guys. Oops, didn't mean to grab that. And then their output, we just plug into the same thing. So the same corresponding rotation axis. So again, the yaw goes into pitch. The roll goes into yaw. And the pitch goes into roll. And then we set that, we set the neck lower rotation variable with the return value of the make rotator node there. Okay, and so it's a little bit kind of confusing, but I think you guys get the idea here. Not too bad, just the graph looks a little messy. And so now that we have our variables created, what we have to do is we have to kind of let Unreal Engine know when to update these variables. And so the way we do that is we take the valid frame and then we plug it into the set execution plug of our set variable nodes. And so since we can only plug this into one at a time, to break this apart, we'll create a sequence. So I'll right click and create a sequence node right here. And then we'll plug the valid frame into it. And then we'll plug the other nodes into our set variable nodes here. So then 0, go into that one. Then 1, we'll go into this one. And then we'll add a pin for the last one. All right, and now that'll take care of creating the variables for us and setting them. And so now, in order to use those variables, we'll want to jump over to our animation graph. And then we'll just come out after these modify curve nodes. And we'll kind of need to translate this data from local to component. So I'm going to right click and create a local to component node. And then we just plug our last modify curve node into it. And then we need to modify the joint rotation. So we'll modify bone, and it's called actually a transform bone node here. And then we take the component pose, plug it in here, and then we grab our variable data. So for this one, I'm going to do the neck lower. So I'll just go ahead and grab it and pull it out. And then this time in the drop-down menu, we'll need to get the neck lower rotation data. So we'll use get, and then we'll just plug this into our rotation slot of our transform bone node. And now, in order to let this know which bone it's supposed to transform, we just select it, and then we want rotation. We can kind of ignore these other guys since we're only worried about the rotation. And so the rotation mode, we need replace existing, and then rotation space, we want bone space. And then the bone to modify, we need to select here at the top. And so this is our neck lower joint. So I'll find it here. Neck lower. All right, and that'll take care of the neck lower joint. So we'll just drag this out a little bit, and then we'll go ahead and just duplicate this. And then that'll keep the rotation settings set up for us. But we need to select the other joint. So this will do the neck upper next. So I selected that, and then we'll need to feed the component output of our old one into the new one. And then we need to grab the neck upper rotation data from the variable. So we'll just drag that onto our animation graph, and then we'll get neck upper rotation, and then connect it to our rotation slot of the transform bone. And then we just do that one more time for the head. So I'm going to select it and duplicate it again. Make sure that the head bone is selected, and then plug these two together and grab the head rotation data. So get head rotation and plug it in there to the rotation, and then we just need to connect this to our output pose result there. Oops, and I kind of forgot to create a component to local node, but it actually did it for us. So that takes the component and transforms it back to local space, some component space to local space. And so that's actually all there is to it. And so now let's see what happens. I'm going to hit compile. And now, just like, maybe not quite like magic, maybe like Unreal Magic, now the head rotation is working properly. And so I've actually had a lot of requests too for how to do eye movement instead of having blend shapes for it. We can set it up so that it can rotate bones instead. And so I'll demonstrate that next. But now that I got the head rotation plugged in, I'm kind of noticing that there's like a little bit of jitter. And so we can actually smooth that out a little bit by going back to our animation graph. And now we'll actually create another modify curve node. And then for this one, we'll select it. And for the apply mode, we'll go to weighted moving average. And then we want this at the very beginning of our graph. So we'll take the input pose or the live link pose and plug it into the source pose for this new modify curve node, and then put its output to our existing modify curve node. And then for the alpha, I usually like to use like a 0.8. That's what they use in the face AR sample. And what that'll kind of do is it'll kind of slow down the values. So I don't know how to explain the math exactly, but it'll help smooth it out. So now if we compile this again and then jump back over here, you can see it looks a little more fluid, quite a bit nicer. And so you can actually play with that weighted moving average a little bit if you wanted to. You could change, the value to 0.5 or whatever. If you have a lower value here, it won't update the scene quite as quickly. And so if your values are jumping around a bunch, it'll make it appear a little bit smoother, but it could also potentially make a little bit of a lag. And so that 0.8 seems to work fine. You can change it to however you want. So now that we got the head rotation stuff all configured, the next thing I want to talk about is how to set up the eye rotation if you have if you need to rotate joints for the eyes. And so this actually isn't necessary for DAZ 3D characters. You get a lot better results if you use blend shapes for the eyes versus joints. But I've had a few people ask me how to do this in the comments, so I'm just going to go ahead and cover it anyway. So the way we set up the eye rotations is similar to how we did the head rotation, but with a little bit of differences. So I'm going to jump over to my event graph here. And then if we zoom in on our evaluate live link frame node here, and we hover over the data results, you'll see that it says that there's data coming in for the left eye yaw and left eye pitch, which would make this process easier. But unfortunately, it seems like with this version of Lively Face at least, that data just comes in with 0 values. And so we can't use them to do what we want right now, or at least that's how it seems to me. But we can get around that by using the eye morphs, like the eye look in and eye look out morphs. And so I'll show you how we'll do that. So the basic idea here is that we'll take the value of both the eye look in and the eye look out, and then see which one is greater, and then we'll use that with a mapped range clamped node to actually drive the eye rotation data. And so I'm going to kind of start here by reorganizing this a little bit. I'm going to move the sequence node back a little bit, and then I'm just going to move this stuff down and out of my way. All right. And so now I'll actually move it out a little bit too. And so now we're going to need to get the property values of the eye look in and eye look out. So I'm just going to go ahead and duplicate this guy and then drag it over here. And we want the eye look in left. Let me make sure that's what it's actually called. Yep, okay. And then we'll duplicate this and make it the eye look out left. And then we'll have these guys get the data from our evaluate live link frame node. So I'll just plug this into the basic data slot here on both of the nodes. And then we need a greater than node to determine which one of these is greater. So I'll just right click and then Can I just put in, yeah, I can just put in the greater than sign here, and then we're going to be comparing floats, so we'll need to make sure we grab the float version of the greater than node. All right, and so now we'll just plug these both into our new greater than node here. And so I'm just going to plug the eye look in left to the top, and then the eye look out into the bottom. And now we'll use a branch node, which will basically just do different things, whether this is true or false. So I'm just going to right click here and then type in branch and click it to bring in a node. And so then we'll just connect this return value to our condition value of our branch node. All right. And so now, if the eye look in is true, we want a mapped range. So I'm going to go ahead and just actually duplicate this one here. And then we want to make sure it's a map range clamped. And then we want to do the in range A. We'll do 0 to 1. And then the out range, we want it to be to rotate the eye inside on the right axis for the Genesis characters. So if we jump over to Daz Studio and then select the eyeball here. Oops, I didn't select it for some reason. There we go. And then zoom in, we can see that if we look in, it's positive on the y-axis. So we'll jump back over to Unreal Engine. And then so with the out range, we want it to be from 0 to a positive 30. And then so this is the true condition. So we'll plug this into, actually we don't plug this into the map range clamp node. We'll do, it goes on a little bit down the line here. And so then we'll create one of these though for the false condition. So I'm just going to duplicate it. And then we still want the in range to be 0 to 1, but this time we want the out range to be 0 to negative 30. And that'll rotate the eye in that outward direction. All right. And so now we'll need a variable to store this the actual rotation value of the eye for the eye. And so we'll just come back over here on the left-hand side in the variables section and add a variable, and we'll call it eye left ya. Sorry, actually to make it more consistent with the with their ARKit naming, I'm actually going to rename that to eye ya left. All right. And so now we'll want to drag this variable. Oops, actually first we need to set its type. Right now it's at a Boolean, but we want it to be a float. So we'll just come over here on the right-hand side in the details and switch it over to float. And now we can drag this into our event graph here. And we're going to be setting the eye all left. So we'll select that when the menu comes up. We'll actually need to duplicate this because we need one for when this condition is true and one for when it's false. So I'm just going to hit Control W to duplicate it. And so we'll plug this the true map range node into this top variable set node, and then we'll just repeat the same thing for the lower two here. And now we need to plug the value in of these map range clamps from their corresponding get property values. So the true condition is for the eye look in left. So we'll just grab the value here and connect it to this value on the map range clamp node. And then that'll take care of that one. And then we just do the same thing for the eye look out left, except we plug it into the map range clamp node for the for when it's a negative, or sorry, for when the condition is false. So we'll do that. And then we just actually have to tell, so this is getting all the values, but it's actually not setting the variable yet until we plug in the this branch into those. So we want to plug the true branch into the positive mapped range clamp node, and then the false condition into the negative map range clamp node. And then this actually needs to be plugged into every time it gets a new live link frame. We want it to go and set either the positive or negative value for our eye yaw left. And so we need to add another pin to the sequence and then connect it to our branch here. And so that's the basic setup. And so now we just need to set up a very similar thing for up and down. So I'm just going to go ahead and take this and move it up, take all these nodes and move them up. And now with them still selected, I'm just going to hit Control W to duplicate them all and then kind of drag them over here a little bit. And now with this new set that was just created from the duplication, I'm going to do change the get property values to eye look up left and eye look down left. And then we need to make sure we plug those into the evaluate live leak frame node, that the data result into the basic data of those two nodes. Now if we jump back over to Data Studio, we'll see that looking up is positive, and then so looking down would be negative. So let's go back over to Unreal. So up is positive, and then down is negative, so that looks good there. And then the only thing is we actually need to create a new variable and for the up and down rotation of the eye. And so let's go ahead and create a new variable over here in the variables section, and we'll call it eye pitch left. And now we'll delete these guys. I actually didn't need to duplicate them, so we'll just delete the new ones. And now we'll drag that new variable in here twice and select set each time. And then we'll connect their data nodes to our clamped range. And then we want these to be set the same way we had the yaw set. So if this is true, we want the positive value, and if it's false, we want the negative value. And then we need to do the same thing with our sequence node over here. Add another pin, and this will just let it know that every time there's a new frame, we also want to do all this stuff and set that variable. So we'll just connect it here. All right, and so that's looking good. And so now that we have those variables set, we'll actually need to change them into a rotator to do the actual eye rotation. And so I could do that here in the event graph, but I think it'll look a little bit cleaner if we do it in the animation graph. So I'm going to go ahead and jump back to our animation graph and then kind of just move out to our towards the end of our animation graph here. And then I'm just going to give us some more room, drag these out a little bit. Okay, and then now we also need another transform modify bone node because we need one for each eye. So I'm going to go ahead and duplicate this. And then this, just to kind of reiterate, we want to make sure that since I duplicated it, it's already set up, but we want to make sure that the rotation mode is replace existing and the rotation space is bone space. But now for the bone to modify, we want to make sure we select that left eye. So let's find it here in the list. I think it's towards the bottom here. Yep, left eye. And now we need to give it the rotation data. And so what we'll need to do is create a make rotator node again. And then we'll connect this into the rotation slot of our transform bone node. And then we need to get those two variables that we set in our event graph. So I'll grab the eye yaw left first, and then we need to get the value of it. And then we also need to get the eye pitch left. So I'll drag that out and get the value of it as well. And then so in Data Studio, the yaw was Y on the Y axis, and then the pitch was on the X axis. And so yeah, even though the Unreal node here says it doesn't match up with it, we need the the actual axis that the eye rotates on. All right, and so that's looking good there. And so now we just need to make sure that this node is part of our data flow here. So we'll just connect it from the last transform bone, and then we'll just connect it to our component to local node there. All right, and so now, in order to demonstrate this, I need to make sure that I'm not using the blend shape data and using it to drive the blend shapes, which is how it has been in the past. So I'm going to just use our strength modifier nodes here. Node here to cancel out that effect. So I'm just going to add a curve pin for the eye look in left. Then we need another one for the eye look out left, and then for eye look up left and eye look down left. And then we want these all to be 0 to just disable their effect. And so by default, they're all 0 already. And I just want to repoint out that you don't need to do this for DAZ characters unless you want their eye rotation driven by the joints. And so that's the only reason we're doing that here, is just so I can demonstrate it. And so now if we compile it and jump back over to our view here, and then we look around, oops, it looks like the pitch there is actually reversed, so that's not a big deal. Let's just jump back over here and then go to our event graph, and I guess these values for the eye look up and eye look down, they're actually the other way around, so we want this one to be -30 for the eye look up left, and then the one for the eye look down we want to be a +30. There we go. Now if we recompile this, we should be good to go. Yep, now it looks, it's looking good. Now it's following the, it's working properly. And so that's all there is to it, to set up the eye rotation, converting the morph data into joint rotation data. And then I'm not going to demonstrate this for the right eye because it's just the exact same thing except for the other eye. So it's kind of funny. After I finished putting this video together, I checked, and apparently there's actually an update to LiveLink Face now, version 1.01, and it says that it does support the eye yaw pitch and roll data now. So I haven't tested it out, but but now you shouldn't have to do this greater than comparison. You should be able to just set it up the same way we set up the head rotation, except you wouldn't need these multiplier values. And so yeah, I just wanted to point that out real quick. Anyway, I hope you found this video helpful. Don't forget to give it a thumbs up, comment, and subscribe. Thanks for watching.